I have pasted the link in the chat box as well as in the calendar. You can refer that. So is my screen visible? Can anyone confirm me?
Yes, ma'am.
Yes, ma'am.
Yeah. So the first question is like, is the system defined by input output relation y of t is equal to x of t plus 1 whole square plus 1 linear? Is it linear or not? So here they have given the input output relationship. So like, can anyone answer this?
No, because if linearity, if any other terms will be added or subtracted other than the input, it's a non-linear system.
Yeah. Correct. So if there is constant over here, is my writing visible? Hmm.
Not yet.
Just give me a second. I think I have some issue with the writing. Okay. Okay, I'll be doing it in the some other thing then. Sorry for the inconvenience. It's okay. Is it visible now? My writing?
Yes.
Okay. So here they have given the input output relationship. And in order to like, there is a small shortcut that one of your friend has told. If the input is added by some constant or subtracted by that some constant, it will be non-linear. And we have known the relationship, right? Like, in order to check the linearity, it has to satisfy the superposition theorem. So a x1 of t plus bx1 of t, if we give the input to the system, then it had to yield a y1 of t plus b y2 of t. Correct? So so if in this case, if we give like this to the system, it will be like a square x of t plus 1 whole square plus, and I'm substituting this term in terms of x. So we'll see how it is going to be. Then it will be b square x2 of t plus 1 whole square plus 2ab x1 of t1 plus 1 into x2 times of x2 of t plus 1. I mean, like I have used a plus b whole square form. That's why we got this, and we'll be keeping it 1. So this will be expected output for a y1 of t plus b y2 of t. But if we do like if we give the input a x1 of t, it will be like a x1 of t plus 1 whole square plus 1 again plus b x2 of t plus 1 whole square plus 1. So as a result here we'll be getting 2, and which is not equal to this. This term is not equal to this. So it is non-linear system. Is this clear? No? Does anyone have any doubt in this?
No, ma'am, clear.
Okay. So like coming to the next question, they have given the input output relationship as y of t is equal to x of minus t plus capital T. So will this be linear? Will this be time invariant or time variant system?
No, it's a time variant.
Correct. So like one thing what I have told in one of the session is for checking the time variant or invariant, it should be like we have to shift it by uh, some constant, and we have to cross check whether it is happening with that. So I'm shifting the input by t naught. So if the output is similar to this, when we replace t plus t naught, so instead of t, we have to substitute minus of t plus t naught plus t. So as a result, what we are getting x of minus t naught plus t. So these two are not equal. So it is time variant system. So first what we have to do is we have to see whether first we have to check, we have to shift this system input by t naught. So I have shifted it, and we have to compare this with the replacing with t with by advancing or delaying with the thing. So instead of t, like I have used t plus t naught, and here also t plus t naught I have used, or you can use here t minus t naught as well. If you use t minus t naught over here, you have to keep over here minus, keep it in the mind. And then after computing, like you check the result. So then we'll be getting this answer is time variant system. Am I clear?
Yes, ma'am, clear.
And these are the solution. Like I'll be uploading it in the drive as well. You can check it. And third question, like 6 minutes.
The first question, why do we need to square the a square, right? Is that correct? Because x of t, in this case, y of t is x of t plus 1 whole square. Why do we need to have a square on b square?
Why we are having that? Like, can you tell me what is a superposition theorem?
So a of x of t plus b of x of t equal to a of y1, right? I mean x1 plus b x2 equal to a of y1 plus a of y2, right?
Yeah. So I'll tell more clearly. If this is the input, we have to get this as output, right? So like why I have done this is, so I have given this as input.
Ma'am, your screen is not visible.
Okay, okay. How about no?
Yep, it's
Yes,
Yes,
ma'am.
ma'am, visible.
So if this is an input, this has to be the output, right? If A x1 of t plus B x2 of t is the input,
Yep.
we are supposed to get output as A y1 of t plus B y2 of t. Am I correct?
correct.
So, like, if this satisfied, it need to be linear. What I have done here is, I have substituted in place of x of t plus 1 whole square plus 1.
Hmm.
I mean, in this input, this is an input, right? So, I have substituted this over here. Since it is whole square, I have squared it. I have used a plus b whole square form. Like, here there is square, right? In the power.
Okay.
Did I clear that? No?
So in place of x of t plus 1, you are
I have
substituting
substituted
a of
a
x of
x1 a x1 of t plus b x2 t. I have substituted this, and like if we substitute this and compute with whole square, this will be in the form of a plus b whole square, right? Like I mean, like we'll assume this term as some p and p plus q. So it will be p plus q whole square, right? I have expanded it,
Okay.
and this plus 1.
Yeah, plus 1 is clear. Okay, thank you.
Yeah. So like we'll see like third question now. Is this for E when we know the condition, right? It should follow x of t is equal to x of minus t. If it satisfies this condition, it will be even. So now in the place of t, we'll be substituting minus t. So already they have given x of t. So here the t is over here. We'll substitute there. So x of minus t will be summation of k is equal to minus infinity to infinity sine of k pi e of jk of minus t 2 pi by 10. So here we'll be getting minus. So it is not equal, like both are not equal. So it will be, it is not an even signal.
Ma'am, we can check it from like for the every value of k, the sign n pi would be 0, na? So it will
Yes,
be
ma'am, that is also the method I used.
this is
So it will be even,
Same
you
here.
are telling.
Yes, ma'am,
Yeah,
because
both
for any
will be
integral
0,
value of
right?
k,
Either
sin pi is
minus
0.
t 0.
Value of k, it will be 0. No, because there is by 100 is there, no, in the denominator.
no, ma'am. You can check the sine function, na? Sine k pi multiplied by e to the power. So we will put k value simultaneously, na? If you put k to be 1, then it will be sine
Okay.
pi, that is 0. Then sine 2
Yeah.
pi it is also 0. Sine minus 2 pi is also 0. So likewise 0 plus 0 plus 0 is giving us to be 0.
Okay. Okay. Okay, I will.
Yeah,
Yeah,
that's
like
the one
feels
way of
like
approaching. Another way is because we are having k minus infinity to infinity, right? So that will also change, right? Minus k will vary the other way, right? Minus 2. So that will also produce the same result, right?
okay. Yeah. Correct. So if we substitute values of k, you are telling it will be 0, right?
Yes, ma'am.
Yeah, like I think I
Because
had
k
to
is going to take up
Nothing
an
but
integral
it is
value.
0.
Okay. Yeah, I got it. So completely it will be 0. Then it will be even. Am I right?
Yes.
Yes, ma'am.
Okay. So we'll solve the other questions. So how about fourth question? Determine if system they have given the input output relationship as y of t is equal to x of t sine omega t. They're asking us to find whether it is time variant or invariant. Can anyone help this out with me?
No, because any other coefficient, if the coefficient of input function other than input is dependent on t, it will be time invariant.
It will be
Yeah,
time
yeah, yeah.
variant, ma'am. Time
It will
variant.
be time variant. Yeah, if it is multiplied, if the input is multiplied with some constant, 1 second.
If we like shift it by d, then x of t minus g, then sine omega t minus g, that will be not equal to the like that function.
Yeah, yes, yes, yes.
Can we say if there is scaling, right? It's WT, right? So whenever there is scaling, it will be it will it will be 10. It will not be time,
No,
right?
no,
I mean, invariant or-
no. If the
No, it will
coefficient
be
is
time
constant,
variant. So, like,
yeah,
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 like you
time
can
variant.
proceed.
Yes, yeah, time variant. I'm saying the other way. Yeah. If the
Yeah,
scaling is
one
there,
of
for example, when we substitute t by t minus t0, right? It will be different, right? Y of t minus
yeah,
t0
yeah.
will be different from.
Yes, yes, yes. So, like, if this is if the input output way in the so if there is if the input is multiplied with some time dependent quantity, so then it will be time variant. For suppose if there is some constant a of x of t, then it will be time invariant. You can check this. So it will be we'll be getting the answer as time variant system. Because if we shift it, if we shift the input by x of t minus t naught sine omega t, and if we replace the t by t minus t naught, so then it will be y of t minus t naught equal to x of t minus t naught into sine of omega of t minus t naught. So which these two will be not equal. As a result, we will be getting time variant system.
The sine term, right, in the first term, the
Okay.
left hand side, it should also should have the w, I mean omega multiplied by t minus t naught, right? Why it should be? Because we are delaying
Like
t.
so, like
It's
the
not so.
rule is like no, it's not like that. It
Okay.
should be like if we like if we shift some quantity in the input, it should reflect in the output as well. Like here, what I'm doing, just I'm delaying the system with the input without considering this.
Oh, x of t is only the input. Okay.
Yeah, x of t is the input. Y
This
of t,
sine
like
sine omega t is given by this function. We do not have to like give it an operation on this.
yeah. It is only the function. So usually, correct what you have told. So usually, what we'll be taking as input as y of x of t and output as y of t of a system. So like here we are delaying it, or we can advance it by some constant. So after the result, we have to get a delay or a delayed version or advanced version of this. So we'll be checking it by shift in case of output here. So which is not happening. As a result, it is time varying system. Is this clear? No?
Yep, thank you. It's clear now. Yep. So,
So like, can anyone tell me the condition for memory and memoryless system? Like, what should be the condition? They have given h of t, impulse response, as sine of t plus 1. Then what?
Impulse response should be a scaled version of the input signal.
It is a memory system, not memoryless.
Ma'am,
It
always
is a,
t equal to a delta t.
yeah, the condition is like, in order to check whether it is memory or memoryless, if it is memory system, impulse response need to be constant times of delta of t. If it satisfies this condition, then it is memory system, or else it will be memoryless system. So they have given h of t as sine of t plus 1, which is not equal to a of delta t. So it will be a memory system. Okay.
So, ma'am, this is basically a simple amplifier, right?
Yeah. Like this is like a amplified version. It is an amplifier, correct?
Okay. And A can
It
be
is an
negative, right?
amplifier. Yeah, even a can be negative. This constant can be negative. Like if it is a kind of amplifier, then it is memory. Memoryless system. It is an amplifier, because if we do like if we do the convolution, x of t convolved with a of delta of t. So as it is constant, we have one property, right? X of t convolved with delta of t will be getting the x of t. So it will be, the amplitude will be like, it is an amplifier version of that. If in this case, it will be memoryless system. Is it fine? No?
Yes, ma'am.
Yes,
So-
ma'am, it is casual also. Sixth option or sixth question, casual.
Why it will be causal? Can you tell me what is a condition for causal?
If h t equal to 0 for all t less than 0.
Yeah. So like here they have given like sine of t plus 1, right? But sine will be like, in general, like sine, if we take sine of sine t, it will be running from minus infinity to infinity, right? So plus 1, it will be shifted version of that. So it will be shifted by 1, and from there it will be starting. Am I right? So here the signal is existing even in the negative time also. So for the condition for causality, in order to check the causality is, if for t less than 0, t has to be 0, then only it will be causal. But here, even though the t is negative, there is some values are there, right, other than 0. So it will be non-causal system. Am I clear? No?
Yes.
Or anyone have any doubt in this?
No doubt.
Yeah. Okay. Now they have given the impulse response of LTI system as h of t is equal to e power t u of t minus 5. So they are asking, is this stable or unstable?
It is unstable, ma'am.
Why?
This is not a bounded function.
Yeah. So in order to check the stability, it has to follow Bibo condition, right? Bibo condition is bounded input, bounded output. So like usually how the we can like if you have possibility once you try to visualize it also how the graph will be. So how the e power t will be looking like, it will be like this, right? I'm telling just e power t. So like here they have multiplied with u of t minus 5. So the signal will be starting at 5. So this is a resulting system and it will be going till infinity. So it is not a, like output is going to infinity. So it will be unstable system. Am I clear? Or you can check with the this condition as well. Is it absolutely integrable or not? E power t u of t minus 5 delta t minus infinity to infinity. If we substitute it, so like since it is starts from 5, it will be from 5 to infinity e power t dt. So e power t, if we integrate, we'll be getting e power t only. And after substituting the limits, we'll be getting e power infinity minus e power 5. So this will be becoming the infinity. So since it is approaching the infinity, it will be unstable. Am I clear?
Yes, ma'am.
Yes, ma'am.
E for minus t, it would have been stable system, correct?
Yeah. For e power minus t, the graph will be like decaying, right?
Yep.
So if you have to see this condition also, u of t minus 5. As it is u of t minus 5, it will be going like this, approaching to 0. This is how the graph will be. So there is no infinity in this case. I mean, it is not since it is tending to 0, it is bounded. Like for whatever values you take, it is bounded. So we will be getting it as, in this case, stable will be getting.
Okay. So if we have another term, e power t multiplied by u of t minus 5 minus u of t minus 8.
Okay.
So would it be stable? Yeah, minus u of t minus 8.
You mean like,
Yeah, correct.
yeah, it will be stable because it is a rectangular function, right? I
Okay.
mean, it will, like, if you see this condition, u of t minus 5 minus u of t minus 8 will be rectangular function, like 5
Yeah.
to 8. So we will be multiplying e power t in that case only. E power t
Okay.
in, if we take in that way, so it will be from the signal, only this green part will be there.
Okay.
So in that case, it will be stable.
Yep, it's bounded. Okay, thank you.
It will be bounded. So in that case, stable. So coming to 8th question, like they have given us the impulse response, which is h of t is equal to e power minus 2t ut. So like they are asking us to find the output. So what I have told, like if you give the input to the system, x of t, and which is having the impulse response h of t, we'll be getting the output y of t, which will be equal to x of t convolved with h of t. So here what we have to do is, they have given the input as e power minus t u of t. So e power minus t u of t need to be convolved with e power minus 2t u of t. So here we have it is a convolution form, right? So convolution is integral minus yeah. Someone is about to ask something or tell something.
I was just telling the formula, ma'am. Nothing.
Okay. You can help me with it.
Xt, that is the input into the h of t minus tau into d tau.
X of
Here
tau.
x of t is the input, e of minus t ut, and then t minus tau d tau. Yeah.
Here not xt. Here it has to be tau.
Yeah, x tau, no? That is e to the power minus t ut.
Yeah. So here, one point to remember is this is not. I mean, tau is not the constant. Tau is a variable over here, and the small t is constant here. This thing you have to keep it in the mind. In this case, in this integral. So we'll be substituting here. So minus infinity to infinity, e power minus t into e power minus tau, u of tau into e power minus 2 t minus tau into u of t minus tau d tau. So as here there is u of tau, it will be from integral 0 to infinity. E power minus tau into e power minus 2 t minus tau into u of t minus tau d tau. So here we have here, since it is from u of t minus tau, so what will be the limits now?
0 to t.
0 to t.
Yeah, it will be from 0 to t. So integral 0 to t e power minus tau into e power minus 2 into 2 times of t minus tau d tau is equal to. So if you compute this, it will be e power minus 2t. I mean, here if you multiply, it will be 2 tau minus tau, right? Hello?
Yes,
Yeah, ma'am.
ma'am.
Yeah. So after computing this integration, so here I will be writing e power, I mean, since I have told here t is a constant, we'll be taking this as constant e power minus 2t integral e power minus tau d tau. Right. So it will be e power minus 2t. So integral of minus 2t is integral of e power minus tau will be e power minus tau by
Minus 1.
minus 1. So we will be substituting the limits over here, e power minus 2t. Since here it is a minus, we'll be interchanging the limits. So e power 0 minus e power minus t. So it will be e power minus 2t, 1 minus e power t. Am I right?
Yes, ma'am.
Second, like here, one mistake I have done. Here minus 2t, I mean here it has to be plus 2t, 2 tau minus tau. Here it has to be plus over here. So like here, did you get why we got plus over here, plus tau?
Yeah, 2 tau
Hello?
minus tau is tau.
Yeah. So here it will be plus we'll be getting over here. So as a result, we'll be getting e power minus 2t. Then we'll be substituting it e power t minus e power 0. Then we will be getting e power minus 2t, e power t minus 4. So we will be multiplying with this. Then e power minus 2t plus t minus e power minus 2t. So it is from, it will be from minus e power minus t minus e power minus 2t.
D option.
So actually it is not the option D, because we have to see there is u of t over here, right?
Okay, so
I
C
mean,
option.
so we will be considering from, I mean, only the positive region will be there, right? Because of u of t. I mean, like, if the duration of this is t1, if the duration of this is t2, then y of t will be max to max t1 plus t2, right? So input is starting from 0 to infinity, and the h of t is also from 0 to infinity. Like if we add this, like the limits will be, we have to add the lower limits and we have to add the upper limits. So as a result, output will be 0 to infinity, right? Am I clear now?
Yes, ma'am.
So it will be from 0 to infinity. We will be getting u of t over here. Then it will be option C. Did everyone is clear with this?
Yes.
Or does anyone have doubts over here? If you want to repeat, I can repeat it as well.
Ma'am, one doubt. When it was like u of tau, then why would the limit has changed to 0 to infinity?
Because I have taken, okay, like here u of t is from 0 to infinity, right?
Yes, ma'am.
I mean, see the thing, I will change the color. So this part you have understood, right? Now I have removed this u of t in the next step. So I have written as 0 to infinity limits. I mean, u of tau ranges from 0 to infinity, and this ranges from, like, since it is negative, I mean, what to say, it will be 0 to infinity. This one will be minus infinity to t, right? I mean, tau, you check the tau here.
Yeah. Understood, ma'am.
Yeah, so we'll be getting 0 to infinity, and then since here it is u of t minus tau, and we'll be taking the common part which is overlapping over here. So it, in the next step, like I have removed u of t minus tau. So like there I have considered limits from 0 to t. I have taken the common region of these two.
Yeah. Understood.
So like how about the ninth question? Do you remember any properties over here?
Yeah,
The
ma'am. We can separate out the parts and derive the like each part convolution. We can like what we call distributive property.
we can use the distributive property. Yeah, we'll be using the distributive property over here. So we'll be getting x of t plus 3 convolved with delta of t minus 3 minus x of t plus 3 convolved with delta of t minus 1, right?
Yes, yes.
So there is one formula like x of
Yeah, ma'am.
t minus t naught convolved with the delta of t minus t1. It will be something like x of t minus t naught minus t1. Shifting property. Do you remember this?
Yes, ma'am.
We have to use this property over here. So as a result, what we'll be getting? So since it is plus 3 and minus 3, this term will be getting it as x of t, right? Since plus 3 and minus 3 will be getting cancelled, and this one will be x of plus 3 minus, I mean, here it is plus 3 and here it is minus 1. So we'll be getting x of t plus 2. As a result, we'll be getting option C.
Yes, ma'am.
Is everyone clear or anyone has any doubt over here? Can I move to the other session, the
Clear,
other
ma'am.
part? Okay. So we'll be doing this now. It will be from, since we know the formula for convolution, it will be from minus infinity to infinity. I'm considering t ut as x of t and u of t as h of t. So it will be x of tau means here I am substituting tau. So tau times of u of tau into u of t minus tau d tau. So since it is 0 to infinity, it will be 1 from 0 to infinity. And this is from minus infinity to 2. So common region will be from 0 to t. We have to see the common region over here. So this will be 1 in this region. And u of t minus tau will be 1 from minus infinity to t. So since we are considering the common area, I mean common portion, it will be from 0 to t tau d tau. Because it will be 1 and 1 d tau. So integral of tau will be tau square by 2, 0 to t. So t square by 2 minus 0. So we will be getting option B. Am I clear? This part.
Yes, ma'am. Clear.
11th question, they have given the, like they have
Ma'am, there
given,
is a eraser symbol on the top of the bar. You can erase all this stuff and write new stuff. No, left side.
uh,
Left side where you have chosen the pen. Above, right?
yeah,
Right.
yeah.
Yeah. If you click this, you will get also option of erase all.
Yeah, 1 second. I'll save this and I'll erase all. That would be better, I think so. Because I have to send this to you, right? This annotated one. So coming to the 11th question, like they have given x1 of t Fourier coefficients are represented by ak. So like according to Fourier series, any periodic signal can be represented as sigma k is equal to infinity minus infinity to infinity ak e power j k omega t, right? So what they are asking over here, like, and they have given x2 as x1 of t plus x1 of t minus half, which is represented by like Fourier coefficients of x2 of t is so will x1 of t Fourier coefficients is ak and x2 of t Fourier coefficients will are ck. So like we will be using Fourier coefficients of shifting property also here. So x2 of t can be represented as, since it is x1 of t, so we'll be representing as same summation of k is equal to minus infinity to infinity ak into e power j k omega naught t plus, and for x1 of t minus half, there is one property in Fourier coefficients, right? If it is shifted by t units, here it Fourier coefficient will be shifted by that constant, right? ak times, if it is minus over here, we'll be getting minus. Here, so minus jk omega naught s. Am I right? I mean, here it is shifted by half. There is one property. I mean, Fourier coefficients will be this. So here s is half. We'll be substituting it over here. It will be sigma k is equal to minus infinity to infinity ak into e power minus jk omega naught by 2 into e power jk omega naught t into t. So like we can common out, so this is common in this. So we can write it as sigma k is equal to minus infinity to infinity ak plus ak into e power minus jk omega naught by 2 into e power jk omega naught t. So x2 Fourier coefficient will be ak plus ak times e power minus jk omega naught t by 2. This will be the option. Am I clear?
Yes, ma'am.
Or do I need to repeat this, or does any other person have doubt over here?
Yes, ma'am. I have a doubt, ma'am.
Yeah.
Uh,
So
I-
option will be C. 1 second. Yeah. Yes, proceed, carry on.
I have a doubt in the convolution. Actually, if I
I mean, in this question or in general you are asking?
in general,
Okay.
if I approach graphically, let's
Huh.
suppose if we are doing this question, t of ut
Okay.
convolution of t. Actually, I'm
Okay.
getting from the graphical method. I am getting okay
You are getting?
the same
Okay, you are
same
doing
answer.
from Okay.
graphical approach.
Yeah, I get it.
Okay. I have a doubt. I want to do a practice question of a convolation from the
Okay.
graphical method. Can you
Okay.
please solve it once?
Yeah.
Let me check once which one.
So x of I mean t times of u of t will be in this way, right?
Ma'am, I'm talking about the other question. It is a simple one. I
Yeah.
will.
Like, okay, tell me the question.
Yeah, u of t convolution with u of t minus 2.
With u of
T minus 2.
t minus 2. Okay. So u of t will be like this, right? U of t minus 2 will be in this way, right?
Yes.
So what we'll be expecting as a result, r of t minus 2 need to be the answer, right? I mean, since u of t convolved with u of t will be r of t, and since it is by using the shifting property, we are supposed to get r of t minus 2. Am I right?
Yes, ma'am. Right.
Yeah. So, like, first, what we will be doing, we have to change the axis to tau in both the
Yeah.
cases. So we'll be changing it to tau, and we have to do the reversal then. Since h of t minus tau, x of tau, integral of x of tau, h of t minus tau d tau. So we are changing it here, and now we have to do the reversal. So it will be minus 2. I mean, minus infinity to 2. So now we'll be shifting with this will be getting shifted with respect to time. I mean, it will be to t minus 2, right? Am I right till here?
Yeah.
So one signal is like this, and another signal is in this way, right? T minus 2. So here we have to consider the product of those two. So here it is 1 and here it is 1. But the common is, I mean, it is not overlapping, right? So it will be 0 in this case. Product of these two in that region. I mean,
But
since if it, yeah.
but we have we will check after shifting, right? We have to
Yeah.
shift
After shifting.
for each and every t.
So, yeah, so it will be shifting in this way, right? So this
After
will
this
be,
we have to after this I have to multiply with both the
yeah,
sides.
yeah.
Then
Yeah.
after multiplying we will get one, right?
Yeah. So
Which is
we'll be getting like this.
not equal to r of t.
So we'll be get we'll be getting so once this gets shifted, so this will be moving in terms of time, right? So this will be moving like this. So like, so when it will start from t minus so from 0, this is 0 and it is 10. So it will be t minus 2. So it will be increasing constantly, right? I mean, 1 minute. In your graphical approach, I'll be telling. So till here it will be 0. But from here onwards, when it starts from here, like let's suppose this graph shifted to here. From here onwards, it will be starting from 0, right? And then it will be slowly like in the next instant, we'll consider this this. So area is growing now. And later, the same signal, this as it will be moving, the area will be growing, right? Under the curve. Are you getting it? So which is increasing directly, right?
How can I prove it? It's a growing linearly.
Then you have to compute this u of t integral by using this. I mean, in order to check whether it is, if we do convolution of u of t into u of t by using this formula, then we will be getting r of t.
For
Shall we
example,
try that?
actually, I didn't get it.
You didn't understand this?
No, ma'am. Actually, for example, I will tell you the stepwise method. First, we take the one of the signal as a h of t for or any of the signals, and then reverse it, then shift it, and then
Yeah.
multiply it and check the common area, right?
Yeah. It
This
is
is the
not the
graphical
common.
approach, not the
Yeah.
common area, and multiply it and just
Multiply and
multiply
we have
it.
to find. We have to
Uh,
integrate it.
yeah, that is the area.
Yeah.
This is the common method, right? For example,
Yes.
in this case, if I take you take u of t minus 2 as a h of t,
Okay.
you reverse
Huh.
it, then
Hmm.
you starting shifting, right?
Yeah.
If we multiply
Till
two
here it
signals,
is clear, no? Till
Yeah,
here
yeah.
it is clear, right?
yeah. For example,
Ma'am, screen is not visible.
Okay.
may I?
Yeah, 1 second. Yep. Carry on. Now is it visible, right?
Yes, ma'am, visible.
Okay. Till here it is clear, no?
Yes, ma'am.
Yeah. Okay.
We shift it, right?
Ah.
In the signals, we learn that if we multiply two signals, we just multiply the amplitudes of two signals, right? Is it?
Yeah. Yes.
For here, for example, if we shift in these unit signals, the amplitude is 1 and the other u of t is also 1 for
Yeah,
greater
yeah.
than 2. It gives, when we multiply, it gives 1, right?
Yes.
And the area is also 1.
Yeah. So integral of so you are telling this will be 1, right? I mean, you mean like x of tau will be 1, h of t minus tau also will be 1, right? Am I right?
Just a second, I will getting confused. Wait, I will write it.
Okay. Should I give you the access to share the screen?
Actually, I am writing it on the copy.
Okay.
Yeah, got it, man. Actually, it's a t.
Yeah, it will be getting t, right?
Yeah. Actually, I am multiplying 1 into 1 after finding it. While finding area, I will multiply 1 into 1. It's a t into 1, right?
Yeah.
Actually,
Like,
I missed it here.
okay. So,
Got it.
am I clear now with the graphical
Yes.
approach as well?
Yeah.
So, area will be increasing now. Here, like I have marked, like for suppose this is 0 and it is at 1 will take. It is 0, it is at some 3. It is at 0.
Actually, you told it's you directly told it's increasing linearly. I actually find from the t into 1. For example, we move towards right with
Oh.
the unit t, and after that multiply 1 into t, that is gives a ramp of t.
Yeah.
That was my approach.
So now you got clear, right?
Yes.
So with this graph also you can understand, right? Like here I have marked the timings as well from 0 to 1, 0 to 3, 0 to 5. The
Actually,
area is increasing.
yeah. Actually, I didn't confused that.
Okay. So 11th one, everyone clear, right?
Yes, ma'am.
Solving. So here they have given like x of t is a periodic signal. So which is having time interval as 2 pi. And x of t is e power t from minus pi to pi. So now let's draw the grid. So this is the input. This is a signal they have given. So and they are telling it is repeating from minus pi to pi. So it is like this. From minus pi to pi. And it is repeating same again in this fashion. This is how the graph be like. It will be so the time period is 2 pi. So if the t is 2 pi, omega is 2 pi by t. So as t is 2 pi, we'll be getting omega as 1. Right? Can anyone respond?
Yes, ma'am. Clear.
Yes, ma'am. Yes,
Are
ma'am.
everyone is clear with this graph how we got, right?
Yes.
Yes, ma'am.
So any signal, periodic signal can be represented as summation of k is equal to minus infinity to infinity ak times e power jk omega t, right? So ak is 1 by t and it will be the inner product of x of t and the phasor. So it will be from in the duration of t x of t e power minus jk omega t dt. Right?
Ma'am,
So
can you
now
please
they are
tell me
asked what should I repeat?
limit part, ma'am?
This limit.
Yeah.
Yeah, like this is a formula in the duration, no? It like this is a formula. It is not from minus infinity to infinity. It is only in the time duration we'll be taking. I mean, in this 2 pi duration only, we'll be considering this. We'll be computing that area.
T2, and we are going to
I mean,
from
it
T.
could
We are,
be. It can be from minus half minus t by 2 to t by 2, or it could be from 0 to t x of t e power minus jk omega t dt, or it can be 1 by t integral 2t 3t x of t e power minus jk omega t dt. I mean, I am telling like in the t duration. I mean, in the time, in that, so okay, if we consider, we can consider it from here as well. We are getting, I mean, in the duration of this time interval, we have to consider the limits. Okay, I'll tell one example. Like for sine signal, a sine signal will be like this, right? So it will be 0 to 2 pi. I mean, one cycle will be completing. So here we'll be considering like 0 to 2 pi. Coming to cosine signal, it will be
Same.
so
Clear,
here
ma'am.
it will be. Now you are clear, right?
Yeah.
In that time duration, we'll be taking this formula according to the convenience. That's why I have wrote ak is equal to 1 by t integral just t I have wrote. I mean, in the time limits you can consider according to the convenience.
Yeah, ma'am. That was I was asking.
So now they are asking us to find a naught. So a naught will be the time interval is 2 pi. So we'll be considering integrals from minus pi to pi. So from minus pi to pi, it is e power t. So e power t, and we will be substituting 0 in terms of k. So e power 0 will be 1 and dt. So we will be getting e power t 1 by 2 pi e power t limits. So 1 by 2 pi times of e power pi minus e power minus pi. So this will be AK, A0. So option will be D. Did you get this?
Yeah, ma'am.
Yes, ma'am.
Yeah. So A naught will be 1 by option D.
Similar questions will be there in the quiz too, no?
I like
Ma'am,
yeah.
previous question there is A5. You have to find A5.
The
Yeah.
question I missed it. Yeah.
Then here it is 1 by 2 pi into answer, but in the mock question there is no 1 by 2 pi.
Yeah. I changed it. I mean,
Okay.
like mock they released in the portal. Is it?
Yes, in my dashboard, that is mock test.
And like I have like I changed the options as well. I mean, I think it is not reflected in that. Once I will talk
Not reflected in
to
my
them.
question.
Yeah, it is not reflected. I will talk to them to change that.
Okay, ma'am.
So like AK is 1 by t integral in the range of t. AK e power x of t e power minus jk omega naught t dt. So t will be, t is 2 pi. And Here it will be taken from minus pi to pi e power t. I mean the same question, like x of t is e power t, in that it will be periodic from minus pi to pi. So it will be e power minus j. So since it is phi over here, k is phi, we'll be taking phi omega naught t dt. So it is 1 by 2 pi integral minus pi to pi e power a. So we'll be taking t common, then we'll be getting 1 minus phi j omega naught into dt.
Ma'am, omega equal to 1, you can put omega 0 equal
Yeah,
to 1.
yeah. So omega will be 1. It will be 1 by 2 pi. So it will be e power 1 minus phi j times t by 1 minus phi j. And we have to substitute the limits. In this question also, like here 1 by 2 pi we have added. I mean, correction is a bit in this here also.
Yes, ma'am.
It will be e power 1 minus phi j pi minus e power 1 minus phi j into minus pi. So we'll be getting in front only. Whole divided by 1 minus phi j. So if we split it up like pi, we'll be getting option A. I mean e power pi into e power minus phi j pi minus, I mean, as we are substituting lower limit here, e power minus pi into e power phi j pi by 1 minus phi j. Am I clear? 13th.
Yes, ma'am, clear.
So here they have given the x of t, and so the time interval is 1. Since it is repeating, and they have given it is an impulse train, and here like t is 1. Like generally impulse train, here we have to get like sigma times of delta of t minus nt, and here t is 1. So as a result, omega will be 2 pi. Then what they are asking us to find, like x of t, we have to make it in the form of Fourier series. So any signal, so we have to find ak. So x of t is summation of k is equal to minus infinity to infinity ak e power jk omega naught t. So first we have to find ak. So ak we have already know, ak is equal to 1 by t in the duration of t, x of t e power minus jk omega naught t dt. So like here first we will be finding what to say. So x of t in this duration, I mean, if we take from minus half to half, only it will be 1 in this at 0, right? I mean, at delta. So 1 by t. So we will be, since it is 1 by 1, we will be taking it as 1.
Ma'am, if we take the limits from 0 to 1, then it is also
So
valid, na?
yeah, 0 to 1 also we can take, but exactly it is in, we can valid, but at one point only we have to consider either at 0 or 1 then.
No.
Why?
We have to split the integrals because there were a discontinuity, right? Between 0 to 1.
Yeah, near, okay.
0
Like
to 1,
near
it is
0 and, sorry?
from 0 to 1, it is 0.
0 to 1 is 0, but like one of your friend has told, like according to Gibbs phenomenon, there will be some discontinuity over here, right? At 0,
Yeah.
there is discontinuity. At 1 also, there will be discontinuity now. So we'll be splitting the signal equally so that it will be in the between. Did you get this?
Okay. Yeah, I got it.
So we'll be taking from minus half to half delta t e power minus jk omega naught t dt. So like delta, what is it? Delta of t e power minus jk omega naught t, what will be? So it will be delta of t only now. So because like if you multiply x of t multiplied with t minus t naught, we'll be getting
X of t
x
naught.
of
X of t. X
T
of t
minus
naught.
tau.
x
minus
of t
0.
naught into delta of t minus t naught, right? This is if there is integral over here, then it will be x of t naught. But there is so since there is the integral. If we consider the integral, then it will be x of t naught. So x over here is e power
E to the power minus j omega naught t.
omega naught t into t. So here t naught is 0. So we'll be substituting it over here. So e power minus jk omega naught into 0, right? According to this formula. Is this step clear?
Yes, ma'am.
So as a result, we will be getting e power 0 will be 1. So ak will be 1. So we'll be substituting in this x of t will be equal to summation of x k minus infinity to infinity 1 into e power jk omega naught t.
Ma'am, is this valid for any interval? I think it is valid for only minus infinity to infinity. That
Here
have
you are
told-
asking.
No, above. That x of t into delta of t minus t naught. Integral.
It's
It is
integral.
limit minus infinity to infinity.
Yeah, it is.
Yeah.
Yeah, it can be from minus infinity to infinity as well.
Any
This
interval,
will be the.
any
So like there is one condition, like this t naught need to be in between that integral. Then only it will satisfy. So this
Okay,
t
okay.
naught, what to say? It is not from any integral. T naught need to be in between that region, whatever we are considering. So we are considering from minus half to half now. 0 is in between that integral.
Yeah.
Understood.
So here we are considering from minus half to half, and it is at 0. I mean, T naught is 0, right? In this case. Then only it
Yeah.
will satisfy. Otherwise, it will be 0. If it is out of that range, means if we take so like I'm telling only in general, not in this case. Okay, like for just it is like this, and if we consider in this integral, it will be 0, which is out. The signal is out of that this region. Clear?
Yeah, clear. This is actually a discrete time signal. No?
Yeah, this is discrete time. That's why we are having summation over here, no? Impulse string. It's 0, 1, 2, 3. This is discrete.
I think this is taught in DSP, digital signal processing.
Okay. Okay. So here omega is 2 pi, right? Substitute. So we will be getting summation k is equal to minus infinity to infinity e power j k 2 pi t. So we'll be getting option A. Am I clear?
Yes, ma'am.
Yes, ma'am.
Yeah. This is also changed. This is a doubt you want to ask. Yeah, someone called me, ma'am. Like this is what you wanted to ask. Hello.
Ma'am, if there is delta t minus n by 2, then what will be the solution? Please
Okay.
show me.
So you are asking if it is
Del t
here
minus n by 2.
del t minus n by 2, right?
Yes,
So
ma'am.
here t will be 1 by 2.
Yes, ma'am.
So impulse train will be 0. Here it will be half.
No,
Here
ma'am.
it will be
Given
minus half.
it is 0, 1, 2, 3. Interval is same. 0, 1, 2, 3. It is given 0, 1, 2, 3. Picture is same.
Picture is same. Okay.
Yes, ma'am.
Hmm.
We have to find delta t minus n by 2.
You are telling this only now. Like delta t
Yeah.
minus.
N by 2. We have to find xt.
You are telling. I mean, this is the same question. We
Same
have to
question
find
only.
Fourier.
Yeah. Same question.
Okay.
Problem is del t minus n by 2. Instead of n, there is n minus 2. T minus n by 2.
Yeah, I got it. Then it should be from half only now. I mean t. I mean impulse train. Like for the impulse train, it will be like this only now.
Yes, ma'am. T equal to half. It is okay. Then range.
Yeah.
What we should take the range?
For the integral.
Yeah, ma'am.
Then it will be integral minus 1 by 4 to 1 by 4.
Yes.
Like because the period here is half, right?
Yeah, ma'am.
And we have to consider, I have take in the time interval only. So
Yes,
it will
ma'am.
be from minus 1 by 4 to 1 by 4.
Okay, ma'am. Okay. Okay, ma'am.
And ma'am, the rest of the solution stays the same, right? Even for t minus n by 2.
The rest of the solution will be saying the same
Okay.
because it won't affect now.
Yes, ma'am. Got
We'll
it.
be getting AK also 1. But
Okay.
here it will change. Near the omega naught will be changing. Omega naught will be, then it will be, since t is 1 by 2, omega naught will be 4 pi, right?
Right.
So near the omega naught, it will be changing.
Okay.
Yes, ma'am.
So, 15th question, like they are asking for power of the signal. So, how can we do this?
Ma'am, squared sum of coefficients.
Yeah. So, from the Parseval's theorem, like what you have told is correct. We have to do the summation of that. So, that is Parseval's theorem, right? Parseval's theorem. Like power will be summation of square of quotients, right? So, like in the question is same from the previous thing, and AK is one, right? In the previous question, this is also impulse train. Am I right?
Yes, ma'am. Right.
So we'll be considering from minus infinity to infinity. So 1 plus 1 plus till infinity, and it will be 1 from minus infinity also now. So as a result, we're getting infinity. I mean, 1 we are adding infinity times now. So we'll be getting answer infinity. Am I clear?
Yes, ma'am, got it.
Yes, ma'am. In every value of if it is real value, AK 1/2, 1/4, anything, then it P will be infinity.
Is it? No, like if it is
If
extending
it is
from
half,
minus infinity,
then what is the result?
if it is half, I
Yeah,
mean, instead of 1, it is half you are telling.
yeah.
So half plus half plus half, you mean in that way?
Yeah, ma'am.
Half plus half plus half plus, it is, if it is infinite times, it will be infinity only, no?
Yes, I am asking that, ma'am.
You are asking only this, huh?
Yeah.
So like, you are asking some doubt, right?
Ma'am, can we solve one question from the previous quiz? I have one screenshot. I can share my screen.
Yeah. We can do that. And in one of the session, you asked one question also, right?
Yes, ma'am. I have also one question from PIQs.
We'll solve that as well. You can ask me.
Ma'am, I have a doubt before you are
Yeah.
moving ahead. In
Okay.
the
We'll go one
last
by
to
one
last
now.
question.
Which one?
Okay.
Yeah, you
In
tell which question.
last to last question. In the last to last question, in the impulse train.
14th question.
Yeah.
Okay.
You say something about the intervals and n/2. Please repeat again, if you don't mind.
Impulse train, you're asking.
No, I am not exactly the impulse train. You say something about the 0 to 1 interval, and after that, someone asks about n/2 something. Please repeat again.
Okay, like integrals, interval, how we are taking, you mean you are asking that?
No, I am
I
clear
mean,
with
I
the
was,
intervals.
okay.
But I am confused. You say something about 0 to 1.
1 second. Did I write it?
I think
Actually,
yes.
actually, ma'am, he is saying that you have taken the interval n/2 now. He didn't understand that. He is confused.
This,
No.
oh,
I am
okay, now,
someone asked about 0 to take interval not from -1/2 to 1/2. Someone told to take interval 0 to 1,
yeah,
right?
yeah, yeah.
After
Yeah,
that,
yeah,
ma'am
yeah.
says something, and after that, I confused. So I
Yeah,
want
we
to.
won't, I got it. Like, we won't be considering from 0 to 1 in this case.
Actually, we can, right?
Like, how?
Actually, if we remember from the previous courses, the periodic signals are those signals we repeat after the interval of time, right?
Yeah, yeah, yeah. True, true.
If we take 0 to 1, at 1
Hmm.
the signals repeat itself. So the required interval is closed at 0 and open at 1, right?
Yeah,
Because
yeah. Yeah.
at 1 it repeats. Hello,
So, but
I'm audible.
yeah, yeah, yeah. You are audible. Yes, you are audible.
Technically, sorry, mathematically we can take it 0 to 1, right?
Mathematically, we can take 0 to 1, but why I am not considering in this case is they are both at discontinuity point, na? 0 to 1. I mean, at
That
0,
was
there is one.
no. I am trying to say that at, for example, periodic signals are those signals which repeat
Which
after.
repeats. Yeah, yeah, yeah.
Exactly. At
Hmm.
0, we take a signals delta of t. After in the interval after some interval in interval 0 to 1, at t is equal to 1, uh, we take the same function or signals, right?
Yeah,
But
yeah, yeah. Correct.
but in interval, the periodicity says that in an interval uh, only a particular signal will repeat. But in this interval, when we take 0 to 1, say exactly the same signal will be repeated at 1. So therefore, uh, the required interval is 0, closed at 0 and open at 1. Is it correct? Or
Yeah, this is correct. Like, this also we can do. Like, but like, I want to just confirm,
Actually,
like,
we are trying to taking k equal to 0. That is the middle point, and we take the limit from negative side
that
to
case
positive
that
side.
case that case is equal to 0, that doesn't come from the putting case equal to 0. It comes from the direct delta function, right?
Yeah, yeah, yeah.
yeah. Like Prince, like just I want to get clarify myself bit more in that, and can I get back to you? That would be better, I think so.
Yeah, no problem.
Because I don't want to give some wrong answer and make you confused. But this time I will
Yeah,
make
cheers.
it a note and I will get back to you. Is that fine?
Okay, okay.
Okay, I can I ping you, or like once can you take G? I mean, send a message in G space so that I can make a note
Okay.
once I get
Yeah,
back.
otherwise we can I will send you a mail.
Okay. That would be fine. Like how about other, like they were asking some doubts.
Yes, ma'am.
Yeah. Should I go with Aditya first or Soma?
You can go, ma'am, with Aditya.
Yeah, Prince, you raised the hand.
Actually, mm, I have a one problem. No, actually, I have a
Okay.
one question. Mm, one question
Okay.
problem. You will take it after that. No.
Yeah, I'll get back to you. Okay, Aditya, like okay, should I you are asking some questions, right?
Yes, ma'am. I need screen sharing access. I mean, if you have to stop sharing.
Yeah.
Yeah, I hope my screen is visible. This is the question.
Yes.
We solved a similar one in this session, but I was not able to solve this one.
So is this even or not an even, right?
Yes.
1 second. I'll make a note of it. Is that fine?
Yeah, sure.
So x of t is k is equal to minus into 15 plus k by e power j k 2 pi by 50. Okay, I have noted the question. Can I explain you?
Okay, I'll stop my screen sharing.
Yeah. Okay. Or hmm. Yeah. The question is x of t is equal to summation of k is equal to 50
Ma'am, screen
minus
is not
50.
visible. Your screen is not visible.
Sorry for the inconvenience. So x of t is equal to summation of k is equal to minus 50 to 50 cos k pi e power j k t 2 pi by 50, right? Question. We
Yes,
have to
right.
find whether it is even or not. So in order to find if it is even or not an even, x of t need to be equal to x of minus t, right? If it is satisfies this condition, it is even. So we will be substituting in place of t minus t. So we'll be getting summation of k is equal to minus 50 to 50 cos of k by e power jk. Since it is minus t, here we'll be getting minus t 2 pi by 50. Right.
Yes, ma'am.
So it can be written as k is equal to minus 50 to 50 cos k pi into e power j minus k t 2 pi by 50. We can write in this way, right?
Right.
So we'll take like we'll assume like minus k is some constant m.
Okay.
Okay. So it will be k is equal to minus, I mean, since it is m, will be taking in terms of m. So cos of minus m pi e power j m t 2 pi by 50. Okay. Till here, are you clear?
Yes.
So we
Ma'am, the
know
limit
like
should be from 50 to minus 50. I mean, m is minus k, right? So,
like we will be considering this is summation, no? It could be of any order.
okay.
So cos of minus theta is cos theta. Am I right?
Yes.
So it will be some summation m is equal to minus 50 to 50 cos m pi e power j m t 2 pi by 50. So other than constant, if we compare this, I mean, if you compare this, other than constant, everything is same for x of minus t. Am I clear? Am I
Yes,
making
yes.
sense over
So we
here?
just changed from k to m, and then we are getting the same thing.
Yeah, we are getting the same thing.
Okay.
But so the constant doesn't matter over here, right? It can be a or b or it can be k. Instead of m, we can write back again k also now.
Okay.
So it will be even.
Okay. Got it.
Okay. And one more question you have asked, right? One question like in one of the session.
Yes, ma'am. That got resolved, though. It's fine.
It got resolved, right?
Yes, yes.
Okay. So limits also you got clarity over there, right?
Yes.
Yeah. Okay then. How about Soma Mandali? You were asking
Yes,
some
yes,
question,
yes,
right?
ma'am.
Yeah, yeah, yeah.
Can I share my screen?
Yeah, yeah. I'll give you the access. Yeah.
Ma'am, is it visible?
Yeah, yeah, yeah. It is visible.
Ma'am, this question. Please tell me the way I have to solve. But
One second, one second. Don't.
yes,
I'm
ma'am.
making the note.
Yes, ma'am.
Okay. So like
Ma'am, another one is here. Fourier. This is, let's a case be the Fourier coefficient of the signal xt. Find the Fourier coefficients of d square xt dt square in terms of a case.
yeah, like here, like in the lectures, professor has explained, right? If you do the derivative of some signal, it will be multiplied by jk omega times that Fourier quotient. Do you remember?
Okay, I can't, ma'am, remember.
Actually, like with the derivative, like professor has discussed that. Like if we in the lecture only, in the lectures
Okay,
only, I think it is in the week 8 only.
okay, okay, okay.
If we do the
Okay, I
derivative,
will.
it will be, yeah, it'll be, for double derivative, it will be like jk omega whole square, it will be there.
Okay,
Oh, so j square means it is -1 or
yeah.
omega square into k square.
Okay, ma'am. Okay, okay,
Then ak will be the result.
okay.
I think option is minus k square. I mean, is that the option, no?
Yeah, yeah. Minus k square 4 pi square t square. Okay.
Now, did you get that? Or should
Yes,
I
ma'am.
write it and explain
No,
this
ma'am.
question?
I will.
Okay, okay.
Okay, ma'am.
Or you can remember a general form of differentiation in
Yeah, yeah. General form of differentiation is like jk omega naught times of ak, right?
yeah, yeah.
Okay.
Like proof sir has given in that lecture.
Okay, ma'am.
Okay. We'll be doing this
Yeah,
question.
yeah. Yeah. Can I stop sharing, ma'am?
Yeah, yeah, yeah. You can stop.
Ma'am, I have a doubt too.
Yeah, yeah, yeah. So
Can I?
can Can we do, I mean, is it the doubt related to the topics which we have discussed before? I mean, in this session?
No, ma'am. But actually, I have a doubt from in the previous year question.
Okay, okay. Yeah. Which question?
Sorry.
Which question?
Actually, there was a question from the convocation. There, the interval comes into the picture, uh, and I messed with those intervals.
Which
Can I
question number? Yeah, yeah, yeah.
can I say?
Okay.
Is it visible?
Yeah, yeah, yeah.
Is this visible, ma'am?
Yes, yes, yes. It is visible. Soma, like, can you wait for a minute?
Yes, ma'am. I'm waiting.
Oh.
Okay.
Ma'am, you can snap it or
Yeah, like I will snap it once. Yeah, you can stop sharing. I will proceed then. Or like, can I go with Soma and shall I get back to you, Prince? Is that fine?
yeah,
Okay.
no problem.
She has asked the first now. Is my screen visible or?
No, ma'am, not
Not yet.
visible.
How about now?
Yes, ma'am, visible now.
Okay. So like T, they have given us 8, right? T is 8. A1 and A minus 1 is 2. A3 is A minus 3 star is 4G. Right?
Yes, ma'am.
So like x of t they have represented as a naught cos omega naught t plus p1 sin omega 1 t. So like usually x of t can be represented as sigma k is equal to minus infinity to infinity ak e power jk omega naught t, right? So remaining other than this others will be 0, right? Other coefficients.
Yes, ma'am.
And we will do one thing over here. We can convert this in terms of cos and sine, right? I mean, there is phasors relationship. Cos omega naught t can be represented as half of e power j omega naught t plus e power minus j omega naught t. And sine omega naught t can be represented as 1 by 2j e power j omega naught t minus e power minus j omega naught t. Am I right?
Yes, ma'am, right.
So we'll be substituting like this and we can compare. I mean, like, so x of t will be equal to a naught into half of e power j omega naught t plus e power minus j omega naught t plus b1 into 1 by 2j. Or we can represent it, this even in terms of sine and cos. This e power j k omega naught t. That also can be done. Like e power j omega naught t minus e power minus j omega naught t. Or we can write in this as well. So x of t can be represented as, like, we know one thing, right? If ak into cos k omega naught t plus, I mean, oh no, we'll be considering omega over here, plus j sine k omega t. Am I right, Soma?
Yes, ma'am. That is right.
So, like, we have to split it. Then, as a result, we'll be getting us is equal to minus infinity to infinity ak cos k omega t plus j's summation of k is equal to minus infinity to infinity sine k omega t. Here we'll be getting ak is multiplied in common. No? So now we have to compare, like, so we have to substitute over here. Like A1 they have given us 2. So, like, so we'll be coming from here. 2 times cos of, I mean, k is -1, -1 omega t plus 2 times, like here I am considering k is equal to 1 now.
Ma'am, sorry for interrupting, but can this question be solved using some symmetry principles? Because A1 is equal to A minus 1 implies that it is even symmetric, and the second thing implies that it is conjugate symmetric.
Yeah, we can use that as well. Yes, we can use those as well. We can use the properties that will be even more easier. I mean, shortcut way.
Can you please walk us through that once?
Okay. So this the in the case of first one it will be even, right?
Right.
And in the case of second one, second. So first property will be even. And
Right. And
second property is real. If it is real, it will be. This is for real. I mean, this is for even. This is for real, no?
right, right.
So like a not like even I didn't try in this way. Like that's what I'm thinking. I'm thinking, can I try it this later, like in the by using the properties, how we'll be getting?
Okay, ma'am.
Okay, okay, ma'am.
So, like we have to do in this way, like we are considering here k is equal to 1 and k is minus 1. So, when k is 1, uh, k is minus 1, it is 2, and I have used the minus 1 over here. And now I'll be doing with the same j into a minus 1, a1 is 2, twice of sine omega t plus again 2 sine minus omega t, right? And again we have to substitute this. So plus 4j plus 4j cos 3 omega t plus 4j cos 3 omega t plus 4j times of j times of 4j sine 3 omega t minus. If we do in this, we have to do in this way and compare this. I mean, after computing the result, we have to compare with the existing one. I mean, whatever they have provided in the question. Then we can, we'll be getting to know A naught, omega naught, B naught, and B and omega 1. So on.
Okay, ma'am.
You can try that. You can compute it and get back to me.
Okay, ma'am. Okay.
Yes, Prince, you told you have some question.
Yeah, I will. To get a snap, right?
Yeah. So here they have given this, and one property which we have to remember over here is u of t convolve with u of t is r of t, right? So they have given x of t is this. Now we'll be using the distributive property over here. So this will be convolved with this, and later, I mean, in this way, right? So it will be we'll be using the shifting property as well. So from the shifting property, if something it is shifted by minus t naught, here minus t1, then resultant will be r of t minus t naught minus t1, right?
Yeah.
So here we'll be writing it as t plus 4. Okay, here there is. Okay. I got bit confused with the braces. Second.
Actually, the convolution with delta inside the.
Okay. Got it. So first we have to convolve this. As a result, what we'll be getting? U of t plus 3 minus 2, right? This part.
Yes.
Convolution of some signal with the delta of t will be x of t only, right? So we'll be getting u of t plus 3 and it is shifted version of that. Here we'll be getting minus 2. Am I correct? Am I correct, Prince, still here?
Minus 2 plus 3, right? Not 3 plus 3 minus 2.
Minus 2. Minus 2 plus 3 or plus 3 minus 2?
Minus 2 plus 3. And we will replace the delta of t minus 2 with 30 there in the u of t, right? This will give u of t minus 2 plus 3.
T minus 2 plus 3 you're telling.
Yes, ma'am.
Both are same only, no? I mean,
Yeah.
like, what? I mean, like,
Yeah.
I mean, both are same only, right?
Yeah.
Uh,
Actually, I just focused on where you replace.
okay. Both are same. Like, so it will be t plus 1 minus u of t minus 5. So it is, so first is this and second is okay. So now we have to convolve entire thing with u of t plus 1. So it will be r of t plus 2, right? This and this.
Yes, ma'am.
It will be u of t minus 4 here. R of t minus 4. Am I right? Here.
Yeah, okay.
So they're asking us what will be x of minus 2. So so this is x of t. So r of minus 2, x of minus 2 will be, here it will be 0. I mean, since it is minus 2, r of 0. So it will be 0 since r of, and here it is minus 2, r of 2. Then plus r of 4 plus 0. I mean, r of 0. I mean, I'm computing
Got
this
it.
expression.
Got it, ma'am.
So you can compute it.
Yeah, actually, I missed the negative sign. I do
Okay.
multiple times, but every time I missed with
Now
negative.
you are clear, right?
Yeah. Got it. Thank you.
Yeah.
Okay, one more question.
Yeah.
In the last session, sir discussed how to calculate the power of a signal in the split systems. Can you
Split system.
refer? Yeah. How can I crack it?
I mean, like, actually, can you be a power signal? Can you come back again?
Means I mean some split systems like k is greater than equal to this, the signal will be this, and for k greater than 1, the system will be this. And then how to calculate the power? Actually, there was a question in the last
Can
session.
you give me the question?
Okay, I will check YouTube.
Okay. Okay. Meanwhile, I'll be explaining Nanda. He posted some question. So, Nanda, are you there?
Yes, ma'am.
So you are asking me why it is not memory less system. You are asking me, is it?
Yes, ma'am.
So, like, in order to know whether it is memory or memoryless, there is one condition, like response, impulse response, which is h of t. It is equal to a times of delta of t. Hello.
Yes, ma'am. Yes, ma'am. That, ma'am.
So like here they gave h of t as sine of t plus 1, right?
Yes, ma'am.
So which is not in the form of a times of delta of t.
Okay.
So it will be memory only, na? I mean, for the memoryless system, the condition is a times of delta of t for the memoryless.
Okay, ma'am.
So here h of t is not in that form. So it will be memory.
Okay, ma'am. Got it, ma'am. Thanks, ma'am.
Prince, you can proceed now.
Wait a while, ma'am. I will check in the YouTube.
Still, anyone else has doubt other than Prince? Like Soma, once I will calculate and I'll also get back to you regarding that question.
Okay, ma'am. Okay.
Hello. Can I present?
Yeah. Sure.
Is it visible?
Yeah, it is visible.
Ma'am, this one.
It's beautiful.
Are you taking a snap or?
Yeah, I'll take snap. Yeah, I have taken.
Okay, thank you.
So like power will be summation of uh, this, right? K is equal to minus infinity to infinity modulus of ak whole square. So when k is greater than 0, so we'll be splitting like this, like in the negative range and positive range. K is minus infinity to 0. K is 0 to infinity modulus of ak. And we can write it in terms of even and odd, like. So here, if we take less than 0, hello,
Yes, ma'am.
yeah. So are you getting this, Prince, what I am writing over here?
Yes, ma'am. You are just
So this is
splitting.
negative part. So we will be taking even part is 0 and odd part will be like, so if it is minus 1, minus 3, in that way, if it is goes, it will be odd, right? So odd is 2 times of n plus 1. Oh, no. This is a form. So 3k into 2k plus 1 whole square. This part. Am I clear? summation k is equal to minus infinity to infinity. This part of quotient is you are clear? Hello.
Hello. Yes.
Yeah, Prince, are you clear why we got this? How we got this?
Yes.
And we won't be considering multiples of 2, right? Here, since it is 0.
Yeah.
And we will be doing this part. No, that is this. So it will be from k is equal to 0 to infinity. One by 2 power k into. So it
Actually,
is even 2k. Yeah.
yeah, go on.
So till this part you are clear, right?
Yes.
Okay. Like
Actually, I solved this question. I am getting the answer, and I do a chat GPT after solving, and I
okay.
found that it shows my solution is wrong. I will share exactly. I didn't find yet where I solved it. I will share with you.
Mean like sometimes every time ChatGPT won't give you correct answer, right?
Yeah, exactly.
I mean, uh,
Therefore, I ask here.
okay, like till here you are fine now.
Yeah, I will share my solution with you.